Sir, this dummy variables are created only when seasonality is considered, correct?
Yes.
So once we deseasonalize, then we directly go with forming of the linear equation or quadratic
Yes.
equation.
Yes. We will be
And
able to go with
sir,
it.
yeah, one more thing, sir.
Mm.
Can you provide some instance where we need to deseasonalize it, sir? One or two examples,
Yeah, so
like how the
take
data.
okay, so take all the examples that we have discussed so far. Okay, so what all the things we discussed on, this was the housing scales data which was there, right? When you have got in terms of the housing sales data, you should be able to look at your business. Okay, in your business, if seasonality plays a very important role, that means you are into hotel business, for example, wherein the sales during your January, February is very less. But during November, December, it will be very high. May to June, it will be very high. And few of the times, it will be very less. So what happens is, practically in all the business cases, what we do is, depending upon how many people will be able to come to your restaurant, depending upon that, your inventory will also change. Your hiring policies also will change. So how many people have to be on salary, how many people have to be on wages. Okay, so temporary basis, how many you have to be able to hire. Everything depends upon this seasonality. Now, if you do not say, or if you do not understand your business properly, if you say there is no seasonality, people come and go in my restaurant anytime. So what I will do is, I will hire 100 employees in my business, and then I will be able to give them some rent, salary, everything else. But what happens is, your fixed expenses will always be high, variable expenses which will be there. You assume that the variable expenses will not be much, because of the reason that you assume that there exists no seasonality. So if you make a mistake of deseasonalizing the data and making the prediction for the next 2 months based upon this data which you have deseasonalized, the results that you get will always be wrong, is for the reason that you never ever captured the seasonality in your analysis. But if you understand your business, you know your business, that in my restaurant business or in my hotel business, seasonality plays a very important role. And depending upon that seasonality, taking that seasonality only, I should be able to forecast it for next 1 year or 2 year. If that is the case, what you'll do is, you will never ever deseasonalize. You will always include the seasonalized data in your equation, and then only you will be able to proceed. Uh, that is what you should be able to look at. Okay.
Sir, so majorly in most of the business cases, seasonality will play a major role.
Yes and no. For example, if you are in the coal business, okay, so, or for example, you are in some government business, or if you take in terms of not in terms of the consumer durables, but if for example you take cement industry, okay, or IT industry, for example. IT industry, why should seasonality exist in IT industry? Because everything, you cannot say that in the month of March and April you will get more contracts, and in the month of January, February it will be less. You cannot say that at all, because of the reason that there exists no seasonality. Demand and supply doesn't change much. It will there will be a trend. The contracts will go on increasing or decreasing, but there exists no seasonality component. So if you take IT data, for example, if finance students are taking IT data, share prices of the IT companies, and doing this analysis, seasonality will not play an important role. But if they are taking, for example, FMCG companies, if they are taking, for example, Walmart, if they are taking for Target companies, then you will be, or for example, automobile companies, wherein seasons play a very important role. Diwali, the sales will be more or less. So during this time, what happens is, you have to include the seasonal component. You cannot deseasonalize the data and then move forward. Okay.
Sir, one last question, sir. So
Yeah,
that
yeah.
means if I have IT company ka data, and if visually I find seasonality, I am
Yeah.
supposed to deseasonalize it, although I visually find the seasonality.
Yeah, but your predictions which will be there, yeah, your predictions, if seasonality exists, Okay, what I'm saying is if I take IT company data, seasonality here means seasonality will not be there at all. But if you find that seasonality component to exist only for few years at all, what you can do is you can deseasonalize the data and you need not consider it. But if you are
Okay.
considering a business where seasonality plays a very important role, never ever deseasonalize that data. Okay.
Okay, sir.
Yeah. So just give me 1 minute, guys. Okay. Sorry, guys. Now, if, your doubt got clear, Sumant?
Yes, sir. Regarding seasonality, yes.
Yeah. So that's why don't.
Sir,
Yeah. Yeah. Go ahead. Go ahead.
again, in the problem statements, we are considering only the seasonality aspect, but why shouldn't we consider the cyclicality aspect, and why should not cyclize it?
I'll come to that. I'll come to that. Okay. So if, you this once every student also probably in the afternoon joins, I'll be able to discuss this in depth. But for all of you, you will be able to notice now that once we have captured the seasonality, this is the results that we are able to get. You will be able to notice that this residual graph which is there, what is the assumption that we are making? The assumption that we are making is there is not much trend component. Okay. So, but when we did in terms of when we looked at the various models that we had discussed, is first we looked at the trend, then we looked at the seasonality separately. Now, what if I want to say that there is additive seasonality refers to what we did right now, okay, wherein we are considering only the dummies which are there, only the dummies, and then we are trying to use this model for further prediction. But you will be able to notice that based upon in terms of the graph, there might be some in terms of additives or in terms of the trend component also. So what if you want to capture the trend component also? So first we'll consider linear trend plus in terms of seasonality. Then we can consider quadratic trend plus seasonality. Then we can look at the multiplicative model here means that instead of taking YT, I should be able to take log of YT. So if I have assumed that this model which is there is able to capture the seasonality, and if I assume that trend is also part of it, what I can do is I can go to this estimate wherein I can take T as nothing but my time trend variable also. This is nothing but linear trend with seasonality. So if I go for OK, here I have to create it. 1 minute. So if we go back to the entire time series which is there, I'll make it as, we'll consider it as at all. And then if we have to generate in terms of the time series for this, generate T equals to at trend. We'll have it as 1945 12, and then generate T2, which is nothing but T into T. Okay, so generate. So once you have it, you will be able to notice we have created this time trend variable which is there. Now, if I go for the quick equation, estimate equation, wherein I want the trend also as well as in terms of the seasonality component also. So what I can do, I can go for H starts. I can take the time trend variable, and then I should be able to take all the seasonal components which are part of it. D8, D9, D10, D11, and then D12. So I have taken the trend also, I have taken the seasonality also. So I want to capture both the trend and in terms of seasonality. And here, if I take the dependent variable as H starts, I'm assuming that it will be an additive model. Okay. If I go for the H starts, if I take the log of the H starts, if I had created another variable called as log, if I go for it, this will be nothing but a multiplicative model. That is an assumption. So if I go for H starts, and if I say, okay, D7, okay, D7. So if I go for it, this is the output that you will be able to get. You will be able to notice most of these dummy variables which are there are not so significant at all. But what we are mainly looking at is 39% of the variation is explained. If I go to view dependent and if I go for the graph, you will be able to notice this did not make much changes to what our results was previously, wherein if I take this H starts previously that we have created for the dummy variables, if I go for this graph, you'll be able to notice the graph almost looks almost the same. There is no changes at all. That means the trend might not be one of the important component of the time series here. So seasonality is the one we should be mainly concentrating upon. So here is one aspect. Now, what is important is if I say linear trend is not good, if I want to go for T2, which is nothing but quadratic trend, if I say okay, and then if I look at the graph now, you will be able to notice this doesn't add anything. Though the quadratic trend has been added to your model, but it is not able to explain much of the variation, and you will be able to notice the residuals, the pattern which was there in the residuals remains almost the same here also, which means there is another component which is nothing but in terms of the cycles. So if this is the case, when we talked about in terms of the seasonality, okay, so here we went to H starts. This is the procedure that we followed. We go to view, go to prox seasonal adjustment, go to moving average method, and then we were able to select either multiplicative model or in terms of additive model. So if I had got this model, for example, this is the way that we went for. Now there is another way of looking at it. If I go for proc, if I go for seasonal adjustment, there is something called as STL decomposition, which is referred to as a spatial decomposition. If I want all the component of the time series to be separated and then given it to me separately, then it will be easier for me to understand time series analysis. So what I'll do, I'll go for seasonal adjustment, I'll go to spatial decomposition, and then I'll take this as it is, I'll not make any changes. And then the data which is there, it is saved in another file, okay, called as H starts Dsce. I'll say okay. Now you will be able to notice this is what is important. If this is your actual data which is there, within this actual data, the trend component which is there, which here represents in terms of the cycles, okay, because there is no gradual increase or decrease. But if from the original data you have taken the seasonality part, if seasonality has been removed, the remaining part which is there is nothing but the cycles part. And if seasonal as well as the cyclical variation has been removed, the only part which is remaining is nothing but the residual part. So you will be able to notice, if you are able to capture the cycles appropriately, there exists the residuals will become random in nature, and thus whatever model that you will be able to come up with is the best model. So if this is the case, what we have not done so far is capturing that seasonal component. So this I'll start it in the next class, but I'll just give you in terms of a brief what we are trying to do now is, if I go for, if I had created this estimation equation, okay, this is what we had done, wherein we had done H starts and we had created all the seasonal dummies. We will not take the trend component because there exists none. And once we had done it, this is the plot that we were able to get. And the this model which is shown in the green color, this y hat values which are there are not able to capture the model because there also exist some cycles. So for going for cycles, we should be able to go for what is called as ARIMA models or ARMA models. So first one is referred to as an auto-regressive model. Then you have got moving average model, as well as you have got what is called as combination of auto-regressive as well as moving average. So if I go for estimate here, I'll just show you in terms of just a few things. You'll be able to notice when it gives least square, it gives you NLS, okay, least square method. Along with that, ARMA models can also be included here. So if I go for AR1, which is referred to as auto-regressive one, and if I say okay, now you will notice, before I can go for it, just notice that when we had done this model, the R squared value was 38% of the variation was explained. Durbin-Watson statistic was able to show that there exists serial correlation. Now what I'll do is I'll go to estimate. Here I will say AR1, which is nothing but auto-regressive one. And then if I say okay, and then look at the results, R squared is 90.8. That means the if you had included these cycles also, 90% of the variation is now explained. The Durbin-Watson statistic, which was around 0 point, is coming closer to 2. Okay. If cycles also has to be captured, we were talking about something called as the stationarity. We were talking about something called as AR, MA, everything else. Why does that come into picture? Is for this reason that after you have captured trend and seasonality, if the cycles are not being captured, we have to ensure that the AR models are applied to the residuals, and once we applied it, now you will be able to notice that the residuals which are there are white noise. Now, if you want to go for forecasting purposes, the model that you should be able to consider for forecasting purposes is nothing but this equation. Okay, so if I now go for the view and look at the output, these are the coefficients along with that the AR model that you should be able to include in your analysis, and using this you should be able to do forecasting. That is what it means. Okay.
Sir.
Yeah.
Sir, so we need not have to do the linear quadratic polynomial.
Yeah, the trend is not there.
Directly. Okay.
Directly you can jump to seasonality, and after seasonality you can come to ARMA models directly. Okay.
Okay.
So you can take a break. We'll join at 1:30.
Sir, will ARMA model be final, or should we compare this model with any other model?
That's what we will be. What we'll be able to do is, after the seasonality component, finding out which model, ARMA model is, it is very, very big. Okay. So within the ARMA models, for example, AR, it can be 1, 2, 3, 4, 5, 6 like that. Moving average can be 1, 2, 3, 4. So what we do is, when we go for ARMA models, there might be 50 different ARMA models which will be there. Among those 50 ARMA models, we should be able to figure out which model is doing good.